This map shows a coordinate plane intersecting a watercolor riverbank. The X and Y axes divide this ecosystem into 4 distinct regions called quadrants. We name them using Roman numerals, starting in the top right and moving in a counterclockwise circle, 1, 2, 3, and 4. To navigate this environment, we follow a simple mantra: watch the direction and the size. Every coordinate pair gives us specific instructions on how to move from the center of the riverbank. Take a look at this coordinate plane over the riverbank. Here is our first problem. In which quadrant is the point -4, 3? We solve this by breaking the coordinates down one at a time. First, we look at the x-coordinate, -4. That negative sign determines our horizontal move. Starting from the origin, we travel 4 units to the left along the x-axis. Next, we look at the y-coordinate. This is a +3. This positive value directs our vertical movement. From our current spot, we move 3 units straight up into the sky blue area. Combining those 2 distinct movements, left then up, places us at our exact location. Looking at our map regions, we see this puts the point -4, 3 securely inside quadrant 2. Isolating each sign and following it in order leads to a predictable result. The coordinates provide the path, and the quadrant is the destination. Let's look at this map again, this time with quadrant 4 highlighted in amber light. If a point is located anywhere inside this specific region, what signs must its coordinates have? We can trace this backward by looking at the spatial boundaries. To reach any location in quadrant 4, you must travel to the right of the y-axis, which requires a positive x value. From there, you must move below the x-axis, which requires a negative y value. Because of where those axes cross, quadrant 4 is defined by those specific movements. A quadrant IV point will always have a positive x-coordinate and a negative y-coordinate. Here we see the moss green region of quadrant 3. We have 2 points with similar numbers, -2, -5, and -5, -2. Do they lie in the same quadrant? Pause the video for a second. Inspect the signs on these numbers and form a hypothesis. Let's check the first point. Both the x and the y coordinates dictate a negative direction. Moving left 2 and down 5 places this point firmly within the moss green boundaries. Now look at the second point. The numbers have traded places, but notice that both signs remain negative. If we move left 5 and down 2, we plot a different location on the map. However, because both points require a leftward and downward movement, they share the same regional boundary. Both lie in quadrant 3. Changing the size or order of numbers changes the exact spot. But identical signs mean the points always share the same quadrant. Let's review the full riverbank map. To find a location, you just read the signs. If both signs are positive, it's quadrant 1. Negative positive goes to quadrant 2. Negative negative drops to quadrant 3, and positive negative leads to quadrant 4. Understanding how signs determine these quadrants is a vital first step. Once you can visualize these movements, you are ready to begin graphing complex shapes and tracking transformations across the plane.